What's going on, YouTube? Decided that we're going to start this video off a little bit different than the other videos because this will be the fourth time I'm trying to record the same video, and so now I'm frustrated. So what we're going to do, before we even get into it, we are just going to load up this pipe full of some Bubba Kush. Nope, we're not grinding it, we're not picking it apart, we're shoving it straight in there and getting down to the point today. Because if I don't, this video is never going to come out. So, what's the topic for today, right? Ooh. Besides me getting too fucking high to do the video. So what we're going to be discussing is the axle differences on these trucks. And now I might have made a video already about this, talking about the differences, but as time progressed, I learn more, I understand more, I have more ways to explain the problem that I hit, and better solutions other than the ones I may have thought originally, and I also now have more axles to show you the difference. Now, don't do what I did. Don't buy the wrong axle the first time. That's a big fucking mistake. But it's a good mistake for you guys that I made it originally, because now I'm going to explain what not to do and what to do and how to get to the end result without making all the same mistakes I did. So look at it as a free educational tutorial on how to rear axle swap your F250, F350 Super Duty trucks. So before we even get into it, why would you want to do this? Why would you want to put that axle into that old truck right there? Could be a number of reasons. You could have a bad axle. You could have an older truck that needs an axle replacement because it's been worn out because of a bearing or something. Or you just may be like me, who wants to keep their original 6-liter truck and doesn't want to spend $80,000 on a brand new one, but wants to feel like you're an $80,000 truck for the cost of some junkyard parts and your sanity and your free time. So again, why would you want to do this? Well, my big reason is that when you get these older trucks, the braking on them is god-awful. I mean, sure, they're better than the 7.3 and all the other predecessor trucks that came before it, but the steering is fucking terrible. The braking is fucking terrible. The suspension is... it's a truck. That's what I will say. But why not fix those problems if there's already an OEM solution to do it? Now, when I say OEM, I'm meaning that Ford had already engineered these parts for their platform, but it was never offered on these years of truck because these trucks predate the Ford revisions. It's a lot of words there. I'm sorry if I'm going fast, but I just want to make sure that I'm retaining everybody and I'm not adding too much information that confuses everybody. So let's hop right into it, and I'll show you what we're working with here. Now, if you look, if you look, this is the new style. Where is my camera? Here we are. This is the new style brake caliper that you're going to find on these newer trucks. Now, despite what you might think, they aren't actually bigger, as in like, oh, they have more pistons or something. By bigger, the pad is physically larger and the bracket is physically larger, so you have more surface area of contact with the brake pad to the rotor during braking. So what Ford had to do is they had to re-engineer the bracket here and stuff, and they also had to consider the fact that the caliper is now covering more of the rotor, so they needed the wheel inside diameter to be larger to accommodate the larger brake. So what that means is your old 16-inch rims aren't going to be able to work on this application. You're going to have to go find some takeoff wheels off of a newer truck or just go aftermarket. I'm personally probably going to be looking for original Ford wheels off of the updated years that somebody took off because they put big fancy chrome rims on theirs and they can't sell them, because that'll be perfect for me and nobody's going to want them in their garage. So besides the brake upgrade, you are getting a couple upgrades on the axle itself, and I'm going to go over them for you guys. So the first upgrade, besides the brakes, that you're going to see is these shock absorber mounts are facing the same direction on both sides on these axles, where on the updated axles, including this one which we'll talk about later, they are opposing. They're, one's going one way, one's going the other way. Can't really tell you what that would actually do. I mean, I'm not sure what the Ford's engineer had seen that sparked his creativity to do opposing, but I would imagine that it is a better design. Besides that, the engineers have now decided that welding these brackets to the actual tube housing was a better solution, and they did it on both. It was a better solution than the U-bolt design that the original ones came with. Now, I'm imagining why the U-bolt design was originally came up with was because the axle was probably used on different vehicles, and this was a cheap and easy way of making a universal axle for different applications without having to physically add more labor time into manufacturing the axle specifically for the vehicle. So that was long-winded. I'm not too sure if that's the case. I have to imagine that's somewhat in the ballpark of right. If anybody knows, feel free to comment. And then another thing the Ford engineers probably realized through the trials and errors of getting these axles perfected was that they originally had only one tone ring or exciter ring. And what that is it's a giant, looks like a giant gear for a bicycle that rides on the outside of the carrier, and it's got little teeth cut into it. And if you can imagine, if every tooth had an opposing recess in the tooth, so teeth and then opposite of teeth, that each one of those, if they're equal spaced on a certain diameter, you could theoretically calculate how quickly this thing's moving by how many teeth pass through a point, through let's say in 1 second, if you can get 15 teeth to travel past point A to point B in 15 seconds, you can theoretically calculate the wheel speed. And that is exactly how Ford did it. So what they do is they add a little special magnetic pickup coil that is mounted on the exterior of the axle housing that sticks into the case, and it hovers right above this, and it picks up every time one of these teeth go by it. And the computer can crunch the number and spit out a speed that will be put onto your speedometer as a mile per hour or kilometer if you're Canadian, and basically tell you how fast you're going. And also it can use that speed reference as a way to know when to shift the truck and all that fun stuff, because it's a good data point for the truck to understand how it needs to lock the torque converter, unlock it, downshift, upshift, and everything in between. Now, the newer style diffs do not have that ring. You can see this on this one. Now, this is not the same as this, but for conversation, if they were, this newer style one would not have that as well. And the reason behind that is because Ford put an electronic locking differential in the newer style trucks, and not all of them, but most of them have it. And the reason behind that is it's better for a couple reasons, but the exciter ring, that ring right there, that is electronically communicating with a sensor into the ECM. If that coil from that locking differential fired and that ring was spinning, any sort of electromagnetic static or any interference would be basically transferred straight into your speedometer and would cause all sorts of chaos in your car or truck. This is why Ford decided to change the design a little bit. So Ford decided that in their new vehicles, and also this was a double whammy for Ford. They were able to add stability control to understand wheel slippage. They put the wheel speed sensors on either side of the vehicle, and these are the new exciter rings, but they're actually physically built into the hub. They're much smaller. The sensor will poke out right there, and it just does the same thing. It reads when the ring goes by it and how many times it goes by it, and based on the RPM and the amount of teeth, crunches some numbers, and it spits out some sort of data point for the ECM to use. So yeah, that's how Ford had fixed the interference problem from the electronic diff to their ring. So they basically moved that part on each side of the wheel, and they kept the diff electronic locking, and everything was happy. Now, what I'm going to try to do here, which I know how to do, is I am going to take this new axle I got, which also comes with the electronic diff, and I am going to remove the electronic diff, and I'm going to add in an air locking differential. So ARB makes an air locker, which uses no electronic magnets, so it's just a solenoid, and I am going to attach the exciter ring to that and drop it into this axle housing, and I'm going to reuse this gear, but the differential is going to be air, and then the exciter ring will be riding on the outside ring. And just to show you that this one does not come with the hole pre-drilled for the pickup coil to sit in here. So if you can imagine, Ford had basically just blanked out this piece in the casting, so that hole doesn't exist. But ironically, they left the meat of the potatoes right there for you, so that way you can get your fingers on it and basically drill and tap a new hole so you can hold your pickup coil in there. And I'm going to show you on the old one. Where it comes in. Now, I don't know necessarily the exact reason behind it, but it looks like they have like a how can I explain it? Like a nut welded to the inner side of the case where that perfectly pokes out. If my camera will focus. There we go. But what I'm going to do is I'm going to get a measurement of how far that pokes out. And I don't know how I'm going to get around that little chunker right there, but I have an idea, which is I could easily add that in, figure out like the hole size and then make a little part, and then I can weld it into the case if need be. I don't think it's necessary at the moment, but that's just something to consider. To me, what they looks like, it looks like they TIG welded a nut with a hole in the middle. That's what it appears to be, but I could be wrong on that. But I'm assuming that's just to keep the sensor nice and stiff so nothing comes up and whacks it and breaks the sensor off. But I don't think it's necessary if you didn't have that there. But, so let's look at the back side real quick. So that meat and potatoes I was talking about earlier, here it is. Now this one's got two little tabs casted into it. Again, probably to keep that sensor nice and tight and right, so nothing comes whipping off and cracks it off on you when you're going down the highway. I would imagine that would be a bad day if that happened. Don't have one on the new design, but that's actually something that I wouldn't even mind building on my CNC plasma cutter. I'd just build like a little bracket with two little walls, and I'd just, maybe bolt it 1, 2, maybe throw one at the bottom or something cool. It doesn't have to be crazy. Just a little shield shroud that'll stop the sensor from getting hit by, I would say, like a flying rock or a stick or something. It'd be nice if it just cracked into this versus your wire or your speed sensor. But yeah, that's basically okay. So besides that little hiccup right there and me trying to get it all of the feng shui, everything else should line up just perfectly. So you're going to be getting a better brake setup with this new axle. Now let's talk about where the axle came out of, because it's not really clear from the beginning of this video where all these axles are from. So let me go backwards here to this project and show you what's going on. That is a 2003 6-liter axle out of an F350. So it is it is a Sterling 10.5. That is a 2017 F250 axle from a 6.7 liter power stroke. Although that is an axle from the HD package of that series. So it's an unusual model, but it is a Dana M275 axle. So it's got a bigger tube diameter, and you can see it kind of chokes down right here. And then it comes up, and then it kind of like chokes down again right about here. It's hard to see on camera, but trust me, it does choke down a little bit in there. And look how massive that casing is. And if those two details don't give it away, that the Dana M series axle. If you come to the front here, you'll see these case spreader holes, which are nice and deep right there, so you can get your case spreader in there and get that thing opened up to drop them that differential. But there was a problem with these axles. I want everyone to be cautious about this, that some of the axles and some of the years of this style axle, Dana's supplier for the axle tubes had to use some subpar metal or some kind of special metal that was not up to standard, that caused the spring perches right here to collapse in on the tube, causing serious irreversible damage to these axles. Highly recommend staying away from these things if you're trying to do a swap, because it's just not gonna jive as easy. I would have loved to have used this axle. I thought it was so cool when I got it, not knowing I bought the wrong axle. But that's a long story. The exciter ring situation would have been a lot more difficult. We would have had to get a custom exciter ring, and getting it to all line up, that may have been its own challenges. But moving past that, unfortunately, this one is going to be canceled. But they are actually compatible parts from axle to axle. So any parts I might need, I might steal off of this one. And then, I'm sorry about getting off track here. So that axle is the axle that's going to be going on that truck. And this axle is a 2016 F250 6.2 liter gasoline motor. And the reason why it is a 6.2 liter axle is because no matter how you look at it, in this particular year, from between the year of 13 to 16, Ford used all the same axles. There was no Dana option that I'm aware of. Somebody's going to correct me, but there was no Dana option back then unless you went with a dually. So what you got was what you got. It was a Ford Sterling 10.5-inch rear axle. And depending on if you had a Power Stroke diesel or Power Stroke gas, to change the gearing ratio. Now, the gasoline models came with a 373, which is the same ratio most 6 liters came from the factory with. And then the 6.7 liter, being a heavier duty, torquier engine, had a higher gear ratio, so it came with a 355 gearing, which basically means you had more available top speed than the gas model because you had more available torque at the same given RPM. Because I'm still using a baby 6-liter motor and I'm not trying to go insanely fast, I'm trying to stay with the original Ford 373 gearing ratio that they gave, but only in the gasoline model axles. Besides the gearing, the axles are exactly the same. The brakes are the same, the axle housing is the same, the calipers, the tubing, everything is the same. So there is no difference. In a lot of ways, I know this is kind of a tangent, I feel like these axles are actually better for a lot of reasons because the tubes are solid. They're not welded anywhere. They're not stepped down. It's just a solid piece of steel that goes from one side to the other. I feel like, just having a solid piece from one side to the other is a better design than having these tapered up, tapered down. I mean, I'm sure it's still a great axle, but I'm positive that axle's thickness is not the same as that axle's thickness, despite this one being a larger diameter is what the engineers were probably thinking. Larger diameter, thinner tube. I would have liked to seen on a larger diameter with the same thickness of tube, but that's not how they did it supposedly. But anyway, so yeah, you're definitely going to want to get the axle that makes sense for you. Now, if I were telling anybody to do this, which I probably would never tell them to do that, definitely go with the 6.2 liter. The reason why is because in order to get the 6.7 liter to work on your truck, you either have to be changing the front gear ratio, which may not be a big deal. You may not have a front gear ratio, which is not a big deal. Or you may be thinking to yourself that, oh, I wanted to, buy a 6.7 axle, blah, blah, blah. And it's like, well, that's great, but you're paying more for exactly the same axle. The difference being is just the gearing. That's it. You're paying more for that point whatever difference in the gearing ratio. These 6.2 liter axles are dirt cheap. This axle came with the calipers, came with the cables, came with all the sensors. I mean, I just took it off already, but came with everything for $560 shipped. You can't beat that. It came with everything. And all I'm going to be doing is just cleaning it up. I don't think I'm going to be changing any of the bearings from the yoke or the wheels out because I just may not have time or money to do that. I'm going to be I may just do the bearings right there for the diff. And I may just drop it in and just kind of clean it up with a descaling tool and paint it and run it. And hopefully everything should be perfect. I mean, it looks beautiful on the inside, so I can't see any reason why I would have to do anything too drastic. But basically, this differential's coming out. The A or B air locking one's going in. And I'm going to have to drill that speed sensor hole and just reassemble it, and that should bolt right into the truck, no problem. I don't see any reason why it wouldn't. And if I didn't mention it, that when you change the front axle and you don't change the rear axle, you're going to have a little bit of a stance difference from the front to back. So by doing the axle swap from front and to the rear, I am going to have the proper manufacturer's width on the truck. The only tidbit to go with that is that I also swapped over the springs to match the truck. So for conversation, I am running a 2016 rear axle and a 2016 rear spring setup, but using the old speed sensor from a 2003. And that's how it's all going to work. Besides that, it's going to be pretty much an easy plug-and-play operation. Yeah, there's a lot of work involved in that conversation, but not a lot of engineering involved. Just a lot of cleaning up, reassembling, and crossing your fingers, hoping that when you turn it all on and you start moving it, nothing sounds like it's grinding or falling apart. But I hope this video helps anybody that's interested in doing these axle swaps. If I can give any advice, like I said, stay away from this Dana axle. Even though it's a great axle probably, stay away from it for your swap and go with a 6.2 liter gasoline rear end axle, because it is going to be the most affordable, most easiest to find. And if you have a 6 liter, you won't have to do any crazy gearing changes. All right, well, I hope this helps anybody.